E2 reactions are bimolecular elimination reactions, and in them, a strong base is attracted to a proton where on an adjacent carbon there is a leaving group. In the transition stage, there are bonds that are formed and broken at the same time. It is one smooth step. The base forms a partial bond with the hydrogen. This bond is partially broken, carbon-hydrogen. Another bond is formed, carbon-carbon, and another bond is partially broken, the leaving group and the carbon. And the result, there is a carbon-carbon double bond formed. The leaving group gets a pair of electrons, and the base the hydrogen. And with this kind of reaction, as in many other reactions with double bonds, there can be many products, major and minor products, depending on what it is. They follow Zaitsev's rule, so use that. And similarly, as in other double bond reactions, the more substituted carbons tend to be more reactive. If there is a hydrogen on a third degree carbon, it's going to be preferred over the second degree carbon because of Zaitsev's rule, where there's going to be a more substituted double bond. That's why that is. And with these reactions, there's also another point to note, is that for this reaction to take place, they need to be in coplanar alignment. They need to be aligned this way or this way. And that is because in the transition stage, these bonds are broken and formed at the same time. It's one step. In order for these new bonds to form, since it's a double bond, it's sp2 hybridized, so it's going to need to be flat and planar for the pi bonds to overlap. That's what this shows right here. As well, I should probably draw a base over here. As the base comes in and begins to break this bond and start attracting the hydrogen to itself, this bond's going to start breaking, but this p orbital will begin to form. And what they're going to need to do is eventually overlap like this. And if they're turned on their side and the x is over here, or something like that, then that can't happen. So it's required that it be in this one, which I drew, which is the lower energy one, or they can be turned 180 degrees. This can be up here. And this is a higher energy one because there can be interference between the base and the leaving group, which are often quite large. But in some rings, they're fused anyways. There's nothing they can do about it, but it can occur.